Okay, to round out this year's lectures for this module from me, a look at CO2 equivalents. It's a short review of some of the issues around carbon, and there will be an exercise for you to do at the end, which is in a related area, I guess. The calculations associated with carbon emissions are complex and perhaps not as well founded as some people claim they are. Many companies in the food sector are taking steps to reduce their carbon emissions, among them Quorn, who are starting to add carbon emissions to their product packaging. There's quite a few. Obviously, any company which uses carbon, which is any company, could potentially do this, so it does go beyond the food industry. But I guess food is an example of a product being placed in people's hands, so it's really quite important and potentially a good way of getting this information across. Obviously, from Quorn's point of view, there's potential benefits in where the company is viewed by its customers. Also likely to save money in terms of reducing their carbon emissions, certainly in the medium to the long term. So, as usual, my webpage is a link there through to Quorn's webpage on this from the image. So carbon emissions are measured in terms of CO2 equivalent per kilogram of products. So again, obviously that applies to all sorts of products. And also non-tangible products as well, though I don't mention this in the notes. You may have read in the news the sheer amount of carbon that's used in producing things like bitcoins. We're thinking about things that are tangible, it has to be said. So there's some CO2 equivalents of various sources of protein, I guess, there on the top, and Quorn along the bottom as an example. It's well known that plant-based, okay, Quorn isn't plant-based as such, but if you like, non-grazing based protein is much lower in carbon than sort of alternatives, particularly beef. There's usual links there, and there's links there to Quorn's information, which obviously should be read in the context of the technical literature on the subject, which, as I say, is a bit complicated. Okay, so the carbon trust. Estimating carbon footprint of an organisation or product is complex. If you see these resources, they'll take you through some of the approaches that can be used. They're not bad approaches, although, as I mentioned a bit earlier on, the underlying assumptions are still uncertain as to the validity of these measurements. It is a very complex area, and it's good that people are developing tools which will help us sort of get a handle on them, but they are far from the final product, I think, these tools so far. Worth having a look at. Yeah, things might have got better. At the start of the pandemic, many people suggested that, terrible as things were, this was an opportunity to reassess the way we run the world from an environmental perspective. Recent data suggests that no such lessons have been learned, and after a huge pandemic-related reduction in emissions in this area over here, beg your pardon, this area down here, carbon is surging again. Links there to the IEA report on this, from which these data are extracted, and also a Guardian report. So predicted to soar to this year to the second highest rate in history, and we're still somewhere from the end of the pandemic yet, it should be pointed out. And the second highest rate wasn't that long ago, and we have sort of made slow and steady progress. If you draw a trend line through them, they're probably going downhill, but only a little bit. Okay, so some definitions. Greenhouse gases, a thing which you talked about a lot, and some good links here to various resources explaining what they are and what their effects are. Basically, they're defined as atmospheric gases that absorb infrared radiation emitted from the Earth's surface and re-radiate this energy as heat. So visible light shines in from the sun through the atmosphere. It's absorbed to some extent, but then hits the surface of the Earth and is re-radiated as infrared radiation, which is then trapped by these greenhouse gases. Hence the term greenhouse. It sees over actually quite a short period of time, perhaps a couple of 100 years since the start of the Industrial Revolution, significant warmings, especially in the last few decades, with consequences which are still unfolding. Okay, so the Kyoto gases. In 2005, the world's first legally binding, I've put that in quotes in the notes, climate change agreement came into force, the Kyoto Protocol, to which 192 countries are a party, aimed to reduce emissions of 6 greenhouse gases by 5.2% by 2012, which is a while ago, obviously, relative to 1990. And as I implied there, the term legally binding has proved to be somewhat optimistic. The Kyoto basket includes 6 greenhouse gases: carbon dioxide, methane, nitrous oxide, F gases, the hydrofluorocarbons and perfluorocarbons, which were used quite a lot in refrigeration historically, and sulfur hexafluoride, again another refrigerant gas. Each gas is weighted by its global warming potential and aggregated to give total global warming gas emissions in CO2 equivalent. So CO2 is the standard which we compare these things to. We notice a little graph showing steady increases there, and there's lots of other information where you can find up-to-date information on what's happening to Kyoto gases, which you should have a look at if you're interested. So global warming potential is another measurement. It's the heat absorbed by any greenhouse gas in the atmosphere as a multiple of the heat that will be absorbed by the same mass of carbon dioxide. So again, CO2 is the standard, and the global warming potential of CO2 is set to 1. For other gases, it depends on the gas and the time frame. The concept was developed to allow comparisons of the global warming impacts of different gases. The science here still continues to develop. CO2 is a good choice as a standard because it lasts a long time in the atmosphere. Other gases last for shorter time but have a much greater impact, as we'll see on the next slide. So gases with high GWPs warm the Earth more than the equal amount of CO2 over the same time period. A gas with a long lifetime but relatively low radiative efficiency may end up exerting more warming influence than a gas that leaves the atmosphere faster than in the time window of interest but has a comparatively high radiative efficiency. And this is reflected in its high GWP, which is the number which is important in the table here. We see some of them are very high indeed. Up to 17,200 times more than CO2 for nitrogen trifluoride, which is a quite unusual gas, it has to be said. Probably not a lot of that in the atmosphere. Some gases are made by both natural and man-made processes, while others, like the hydrofluorocarbons, are only the result of human industrial activity. And there's more links to it there for background reading if you're interested, as usual. So carbon dioxide equivalent, which is what the lecture is ultimately about, CO2E, they're sometimes described as. It's a metric measure used to compare the emissions from various greenhouse gases on the basis of their global warming potential, GWP, which we've just looked at, by converting amounts of other gases to equivalent amount of carbon dioxide with the same global warming potential. So it allows things to be measured by standard. Carbon dioxide equivalent of gas is derived by multiplying the tons of gas multiplied by the associated GWP, and often express these carbon dioxide equivalents in million metric tons of carbon dioxide equivalents, abbreviated as MNTCDE. Again, if you read up on this in context of agriculture, food production, food movements, and anyone else that uses carbon dioxide, you'll see these figures included here, which is why I include them. People who write them up in papers assume everyone understands what we're talking about, but it's not necessarily the case. So it's worthwhile understanding definitions always. Somebody always say to students when you're writing reports is, if you're using a definition, define it and reference it. This is a website that allows a simulation of consequences of different global warming scenarios. Interestingly, the headline figure from when I took this screen grab is now an increase of 3.6 degrees C by 2100, so about 80 years from now. This smaller value is a smaller value from about a year ago. It's about 0.5 degree, yes, from when I collected this screening image. Maybe due to pandemic-related issues. I haven't read the website in detail, so if you have a read, it may talk a little bit about why they are suggesting a slightly lower increase. Still very significant, it has to be said. But perhaps the rate has slowed down over the past years, though. Bearing in mind the information we saw in the previous gap showing the return of global warming activities, maybe next year we'll see it back up again, regrettably. Okay, environmental impacts of food supply. I've gone back and forth on this. I was going to have you looking at various definitions, but I've just come up with an idea of looking at a related area, I guess, which is perhaps associated with food waste. In my background reading, I came across this paper on tilling food, which has some information on various ways in which we can use to measure carbon dioxide. Now, let me just go back a second. Let me just check here. Now this is the paper I was talking about. So SOMA. So SOMA includes a concept called the right to food. There's a link there on the right to food, talking about what it is. And essentially it's a way of making sure that the agricultural industry doesn't lose food. It gets put in people's hands and people's plates. So here's something for you to do before Thursday. Have a review of it. Briefly summarise what the right to fork food concept is. You might have to do a bit of reading outside the paper. As I mentioned, there's a link there which has some information. It takes a little while to open that link, it has to be said, but there's some stuff in there. So summarise from non-technical audience the way we normally use images to help clarity, and maybe we can post through MS Teams during the session. Just again on alternatives, something again I read recently. A suggestion that the EU could greatly reduce its carbon emissions by embracing GM crops. The article's included in the notes, and it's linked through from here. The original paper is in the preprint, linked on the BioRigsvin server. A preprint is a version of a scholarly or scientific paper that precedes formal peer review and publication of peer-reviewed scholarly or scientific journal. It's often available free before the paper is published in a journal for comments. So have a read of the paper and see what you think about it. It's just linked through from there. It's probably the quickest way of finding it. I think there's a new scientist article which I'll probably add to the notes as well. Right, okay, that's all I've got to say about that. Thanks for listening.